Right, this video is going to talk about exponent properties and basically the multiplication properties of exponents. Now, first of all, we want to remember that exponents really represent multiplication already. They're actually a shortcut to multiplication. So notice the problem up top here. We've got 4 2's all multiplied together, a couple of x's still multiplied, right? And then about 5 y's over here. 1, 2, 3, 4, 5 y's all multiplied together. Now, instead of having this what we call expanded, right, and this really long-looking statement, exponents basically just give us the opportunity to write things with a little bit, shorter, kind of cleaner writing. So again, if there are 4 2's all multiplied together, we can say that that is 2 to the 4th power, right? So it kind of shortcuts that statement a little bit. Same thing, since we have 2 x's multiplied in the middle here, we can say that x is the base, as we call it. The base is raised to the 2nd power. There are 2 of them multiplied together there. And then finally, because we again had 5 different y's all multiplied together, your base is y and your exponent would be a 5. There's 5 y's all multiplied in there. And again, that would be a simplified statement, right, using those exponents. Now, if we didn't want to leave things sort of in what we call exponent form, we could take one more step and realize that, again, 2 to the 4th is really 16. And again, that's just multiplying that out, right? 2 times 2 is 4, times another 2 would have been 8, times another 2 would have been 16. So again, we get that number. So now that's in sort of more of a simplified form. The exponent form, again, is what I circled over there at the left. So we would have had 16, but since we don't know what x or y are, we can't really find those. Now, our goal is really at the bottom here. Notice we have sort of more complicated statements. We have statements with parentheses in them, right? And we also have some statements where we have multiple, bases here. We've got x times another x, kind of like we did up top. It'd be nice to be able to write that as one single statement, right? Simplified statements. You'll notice up top here, to simplify means to combine. So kind of not write them as 2 separate things, write them as a single thing. Or cancel everything possible, right? Kind of get rid of anything you don't need, including eliminating any parentheses. If we don't need those parentheses, how could we write that in a simpler way? Well, if we think about these as expanded ideas, let's come up with some shortcuts. So over here at the left, we're saying x squared, right, times x to the 5th. If we wrote that out in sort of an expanded form, really we just have 2 red x's there and 5 blue x's. Really all together, there are just 7 x's all multiplied, which in that case means this is really x to the 7th power. Now, rather than having to write out that expanded form, right, if we didn't want to have to write all that out, what would be an easier way, right, to write that out? Well, if we know we've got x squared times x to the 5th, well, 2 and 5 add up to 7, right? So a shortcut for that might be saying this is really x to the 2 plus 5 up in that exponent, right? 2 plus 5 up there, and again, we'll still get x to the 7th. So we'll talk more about that rule here in just a minute. The same thing goes for the one in the middle there, x squared to the 3rd. Well, if we wrote that out, that's really x squared times x squared times x squared, and all separated, right? Grand total, we really have x to the 6th. Well, how could we have known right at the very beginning that would be a 6? Well, if we have what we call power to a power, right? We've got 1 power, x squared, to another power to the 3rd. Isn't 2 times 3 the same thing as 6? So really, instead of having to do all this expanded work, right? Instead of expanding that all out, we could have just said that this is really x to the 2 times 3, right? All up in that exponent, which would give us that x to the 6th for a final answer. And then finally over here at the right, well, xy to the 3rd is really just all of those written out. If we sort of regroup them, everything's multiplied. We'll use a little bit of commutative property here. We can reorder these. There's really 3 x's and 3 y's. So again, I would say that that's x to the 3rd and y to the 3rd, but we no longer have those parentheses, right? We don't want that stuff grouped inside the parentheses. We got rid of the parentheses by sort of expanding that out. Well, it's not quite a distributive property, but doesn't it sort of seem like I just took that exponent and we said x to the 3rd, And again, same thing, y to the third. Or if we wrote it out, kind of using that rule from the middle, this was x to the first previously, right? And we took that part to the third. And we had a y to the first inside previously. And we took that part to the third, right? And really, power to a power, again, kind of like we said here, we could just multiply. So that becomes x to the 1 times 3, or 3, and y to the 1 times 3, or 3. So we get that nice statement right there. Let's try a few more ideas here, a few more examples. So again, that first example that we had, x squared times x to the fifth, we said the nice shortcut was, let's just add our exponents. This becomes x to the seventh. And again, that rule is called the product of powers property. Now, the name isn't quite as important as how you're doing it, but it makes sense. The product, we're multiplying, of powers, right? A to the m, a to the n up here. And if you have a product of powers, you're multiplying, as I like to say, with equal bases. It's a to a power times another a to a power. Then we get a single a, and we just add the powers. So in the middle, same idea. This would really become y to the 3 plus 4 plus 2. Right? If they're all y's, then we just add the exponents, and we end up with y to the 9th. And over here at the right, we'll notice I've got x to the first, right? If there isn't an exponent written, we call it a 1, times x to the 6th. Well, that's going to become x to the 1 plus 6. But now notice y is not the same variable, so I can't combine those. So this just became x to the 7th, y squared. We can't combine the rest of that because, again, they're not like bases. They're not equal bases, right? They're not the same variable. Another rule we looked at, again, there was this power to a power, right? We've got a to the m raised to another power, or basically x squared raised to the third. And we said in that case, let's go ahead and multiply our exponents. And again, if you get a single base to a power, and then that whole statement to another power, we're going to multiply m times n up here, multiply those exponents. So this just becomes 5, again, to the 2 times 4, or 4 times 2. This would be 5 to the 8th. And again, that's the exponent form of that statement. If we wanted to know the actual number, again, we could always pump that in a calculator, right? 5 to the 8th is going to get pretty darn big. I know 5 to the 2nd is 25, 5 to the 3rd is 125, 5 to the 4th is 625. But again, after that, they start to get pretty big, right? And I was only up to the 5 to the 4th. So we're going to get really big numbers there. Again, feel free. You can always use a calculator and kind of figure that out if you wanted to. But again, a lot of times we'll leave these in exponent form, right? If we're just simplifying, we're just trying to get in an exponent form. One last rule again, and then we'll go maybe try a couple of examples. Point out a couple of simple things for you as well that'll help with these. If we're multiplying inside the parentheses, both parts are to the m, then we can separate, right? We can say that the first term, or the first multiple there, first factor, a is to the m, but also b is to the m. This is the one that looks kind of like a distributive property, only we don't want to get it confused with our old distributive property. We just want to remember, I'm going to take both parts to the m. So down here again, this just becomes x to the third, y to the third. Or here, this is going to be 2 to the 4th, x to the 4th. Realize that number in front of x, remember those are two separate factors, right? Just like x times y, this is 2 times x. Now careful when it comes to the negatives. Technically we have 3 things multiplied in there. There's a -1, there's a 2, and there's a w. So what we want to be careful of is this becomes -1 squared, 2 squared, and w squared. Which in that case, -1 squared is 1, 2 squared is 4. Well, and 1 times 4 is just 4, correct? And I can write it out, but I'm going to have to write another step now. And now I've got a w squared, which makes that 1 times 4 is really just 4w, w, don't change the variables there, squared. Down here at the bottom, notice that the negative isn't inside the parentheses, so that -1 doesn't receive that exponent, right? That -1 is already in front. So really this becomes 2 squared, w squared. And in that case, well, -1 times 2 squared is going to be a -4 w squared. So notice that time the negative stuck around. If because it wasn't canceled, right? That exponent didn't cancel it away. That brings up another important idea. When we're talking about exponents, if you have a negative number raised to an even exponent, think of that as I've got 4 different negatives, right? Negative 1, negative 1, negative 1, negative 1. You've got negative 1 4 times, which means that, again, 2 negatives multiplied makes a positive. All of those negatives are going to cancel away, right? All those negatives are going to cancel each other away. And basically, we're just going to end up with a positive, right? 256, right? A couple of 4s multiplied, and then the rest of those multiplication. If that were an odd exponent, though, negative numbers to an odd number, again, I've got a negative or an odd number of negatives, which means even if I cancel them away, I'm still left with one of those negatives sticking around, right? And the basic idea there, it's going to stay a negative number then when I get my answer. One last idea, it's called the order of magnitude. You might need this in your homework. Order of magnitude is another way to refer to a 10 to a power. So the order of magnitude of a number basically says round that number to the nearest power of 10, and then let's represent it as 10 to a power, that power being its order of magnitude. So 91,000, right? I would want to think, is that closer to, well, if I put a 1 right there, is that closer to 10,000? Or is 91,000 closer to the next power of 10 up? Basically another 0, is it closer to 100,000? Well, I would say 91,000 is only a little away from 100,000. Right? It's only 9,000 away there. It's 81,000 away from 10,000. So I would say it's closer to 100,000, which is 10 to the 5th power, which means its order of magnitude, again, is going to be 10 to the 5th power. Same thing goes over here at the right. Well, now you'll notice, again, there's a 1 here already, which means 12 million, and I'm really not that worried about the rest, but 12 million is much closer to 10 million than it would be to 100 million, right? Than putting another 0 on there. 12 million is pretty close to 10 million, which is 10 to the 7th, and again, that's its order of magnitude. So if you have questions on order of magnitude, make sure you talk to your teacher. Also, if you have questions on your exponent properties, you can talk to your teacher as well. In the end, though, hopefully this helps you simplify. Good luck and have fun.